Okay, so today we're doing our review of Unit 2. We're going to combine all of the things that we've learned in this unit. So you definitely need your notebook. Just looking for mine. So just as a brief overview, we started with reviewing what is a function and evaluating them. So plugging numbers in. Then we talked about function families and graphed. We spent a little bit of time graphing the function families. Determine domain of a function, whether intervals are increasing or decreasing, and rate of change of a function. So on this paper, you can see that we're combining all of those things. We have 6 problems, and for every problem, we do that. We evaluate, we graph, we talk about the transformations, what's the domain, increasing or decreasing, and find the average rate of change. So make sure you put your name and your period on it, because you are going to turn this in. And the page that, one of the pages that may help you the most is page 17. So that may be where you want to go. So first question we have is a square root function. And our first task is to evaluate this function. So I'm going to show you how to plug it in, and then I'm just going to call your names for you guys to give me the values. So our first one, if we plug in a 3, what that is going to look like is 3 minus 3. That's under the root. Make sure that that's under the root. So I plug in a 3. I replace the x with a 3. And then on the outside, we have a plus 1. So I like to use Desmos for my calculator, but not the graphing part. I like to use the calculator part. So I go to Desmos.com. I click on Math Tools, and I always choose the scientific calculator. I like this one because it shows you where all of the buttons, well, it doesn't show you, but the buttons are easy to find. So I will make mine bigger. The root function is on your left-hand side. Underneath that, you plug in 3 minus 3. You have to arrow over to get outside of the root, and then do plus 1. That gives me 1. So my first point that I'm going to graph, but I'm not going to do that until I have all of them, is 3, 1. So now you are plugging in 4, 17, 12, and 19. And I will just call your guys' names for you to tell me what they equal. So everybody's name will be called today, and it'll probably be called 2 or 3 times. At this point, we are just evaluating the function. If you need help knowing what to plug in, I have it on my screen. Give you roughly 30-ish. $20. $10. Okay, Nick, what did you get for x's 4? Thank you. Ivani, what did you get for x's 7? 3. Aaliyah, what did you get for x's 12? Naughty Leah. Let me check. Yeah, what's your name? Elia. Sorry, babe. Elia. Were you able to get 12? Thank you, dear. And Hugo, what'd you get for 19? 5? You guys agree with those? Okay. So the next question is, what is the parent graph of this function? Well, the parent graph is y equals root x. So if I go back to that page that I told you might be helpful, I can find the parent function. That's number 4. So I know that this function is one of these weird ones that looks like a sideways parabola where somebody cut half of it off. So he's one of these ones that has a point on the end and an arrow on the other, and he looks kind of weird. So what did we do to that parent function? Well, we come up here and we move left to right. So if there's a negative in the front, we reflected. We didn't do that. And if there's a number, we did a shrink or a stretch. We didn't do that because nothing's there. So that means that we shifted up or down and left or right. Inside, trapped with the X, that tells you if you went left or right. So which direction did we go? Right. So even though it says -3, when it's trapped in with the X, you do the opposite. So we took this parent function and we shifted it to the right 3. And then did we go up or down? Up by 1. Well, when we say we shifted right 3 and up 1, what exactly did we shift right 3 and up 1? Most of the time we're talking about this vertex. You can think about it kind of as like the center or like the starting point of your graph. So we took this vertex that used to be at 0, 0, and we shifted it to the right 3 and up 1. And if you notice on your table, that is the first coordinate that you found. So your vertex is now at right 3, up 1. Then the next point is 4, 2, and I'm getting these from your table. Then 3, just kidding, 7, 3. So 4, 5, 6, 7. And then our next one would be 12, which is off the grid. You can estimate it if you want to. But I know with these 3 points, this graph is looking like this. How do I know that? Because this is the parent. So it looks like one of these weird ones that has the dot on one side and the arrow on the other. So mine's not perfect, obviously. You just do the best that you can. I highlighted mine a little bit just to make it clearer. Okay, so then the next question it asks us is, what is the domain of the function? So remember, when it asks about domain, it's always referring to the x values. So they want us to determine what are the numbers that x can be. So my lower bound, if I go to this graph, the lowest point that I can have, or the leftmost point, is +3. And we talked about this when we reviewed domain, that if the point is colored in, it can equal 3. So I'm going to draw a square bracket around that. Comma. Then where is this arrow telling us this function is going? Infinity. Very good. And remember, infinity is an idea, so we don't use a square bracket, we use a parenthesis. If we want to use interval notation, you put x first always. X first always. You point your inequality in the direction of the arrow, and it can be an equals to. And then you put the number in the interval. You never put infinity in an inequality. If you have less than or equal to signs, you never put infinity next to them. Okay, so then our next portion is asking, for the interval 3 to 7, is the function increasing, decreasing, or neither? So I luckily have 3 to 7 graphed. If you want to, you can like mark it so that you can see it better. They're asking about what is the function doing in this section. So just that part of the graph. Is that going up, going down, or staying flat? It is increasing. So we've evaluated, we've identified the parent, the transformations, we've graphed it, talked about domain, looked at one of the intervals, and the last thing that it's asking about is find the average rate of change for this function from 7 to 19. So this is what we talked about last time, where 7 is A and 19 is B. Now we could use the graph if we had the graph, but we didn't go out that far. So let's just go to the table and use our table. So 7 is A, 19 is B. So that means that f of A is 3 and f of B is 5. Well, why do I have to know those things? Because that is the formula for average rate of change. You do the function at B, subtract the function at A over B minus A. So now we just need to plug all those into our formula. And I'll write it on this page, but you don't have to write it. It's just there for your reference. We fill in these values. So from the table, f of B is 5, f of A is 3, B is 19, A is 7. If I plug that, I want to see what Desmos will give me if I plug that in. So fraction button, 5 minus 3 over 19 minus 7. So it gives me a decimal, but if I want to know what the fraction is, there's this little button right next to it that has a box over a box. That'll change it back. So I'm going to leave this as 1 over 6, or I'm going to write it as 1 over 6. So the average rate of change between 7 and 19 is that you go up 1 over 6, up 1 over 6. So this one problem covers every single thing that we've talked about in Unit 2. So now let's do it again for a new function family. This time our function family is the quadratic family. So you're going to go through just like you did on the last one and evaluate this function at the x values I have given you. So -3, -2, -1, 0, 1. But this time, because of the exponent, make sure that you are super careful to use parentheses. If you don't use parentheses, your values are going to be all weird. Okay, you guys give it a go, and in about a minute, I'll call on you to give me answers. Elia. Oh, Piper. About 30. $20. $5. Just kidding, 10. $5. Okay, so I'm just gonna use sticks, and everybody's stick is in, so you might get called on again. For x is -3, that one goes to diamond. -14. Is that what you guys got? That sounds big. $4. Oh, you didn't use parentheses. If you don't use parentheses, you get -14. So 4, which would give us -3, $4. -2 goes to Zane. -1. Okay. -1 goes to Elizabeth. -4. 0 goes to Cheyenne. And 1 goes to Britain. -4. So then these are our points: -2, -1, -1, -4, 0, -5, 1, -4. So next question is, what is our parent function? So we could go to our family functions page and find which one has an x squared, and it's the first one. So what we have looks like a parabola. So our parent function is y equals x squared. The next thing that we do is determine how have we transformed that parent function. So our guide for that, if we need it, is this thing. There's nothing on the front of our function, so we didn't reflect or change the size. And there's nothing trapped inside with the X, so we didn't go left or right. But there is a plus on the end. So did we go up or down? Sorry, there's a minus on the end. So did we go up or down? Down. How many? 5. Hi. What's your name? You can sit at that far. Okay, so that means that we took this vertex at 0, 0, and we shifted it down to 0, 5. So I'm going to write that down. Our vertex is now at 0, 5. And if you, sorry, -5, my bad. If you look at our table, you can see that we did find our vertex. So now that we know what this is supposed to look like, we can plot these points. We have a point at -3, 4. -2, -1. -1, -4. Our vertex at 0, -5. And then 1 at 1, -4. Hopefully we're remembering that parabolas are symmetric. So if I have a point that's 2 to the left here, then I also have a point that's 2 to the right. And at y is 4, if I have a point that is 3 to the left, I also have a point that is 3 to the right. Because parabolas are exactly symmetric. And now I can use that to sketch what this looks like. How do I know it looks like this? Because I looked at my page 17. Page 17 told me that function families that are quadratic look like a U. So now that we have this, what is the domain of this function that we just graphed? If you need help, you need to go to the domain page on 21. You look and see what is the lowest your x values can be and what is the highest your x values can be. So what is it? Oh, you want me to pick 6? Excellent. Hugo, do you know the domain? Nope. Raul, do you know? Fernando? Negative infinity to positive infinity. The domain is all of the values that x can be. And even though these look like they're going up, what that means is this just keeps getting wider as the function gets bigger, as we plug in more x values. So the domain of this function is all reals. Okay, next up, it wants to know for the interval -3 to 0, is our function increasing, decreasing, or neither? So -3 on the x, I'm just going to mark that. To 0 on the x-axis. So Beth, is that increasing, decreasing, or neither? This one that I have highlighted. I can't hear you. So if you move from left to right, is your pencil going down or going up? Decreasing. You all need to be on the same number as me. Do you understand what I'm saying? Do you all understand what I'm saying? Yes. It's annoying when I ask you the question and then you say to me, which one? Be on the problem that I am on, please. Okay, the next one is find the average rate of change from -3 to +1. So -3 on the x's here and +1 is here. So they're asking for the rate of change between these 2 points. So hopefully with me drawing that line, you guys can see that that average rate of change is going to be negative. Because if I connect the graph where it's -3 to +1, that's not +1. You can see that this line is going down. So just like on the last problem, we are going to use our table to find the values that we need for our formula. -3 is A, 1 is B. So you go up to your table and you find f of A, that means what did you get when you plugged in -3, and you find f of B. That means what did you get when you plugged in 1? I will be pulling sticks, so please be calculating. Hello. Okay.
Check, see if there's any extra ones that make sense. So get you a Wi-Fi access point for Wi-Fi.
Okay. Sure. Okay, about 10 seconds. Three, 2. Okay, Nick, what did you get for f of B? So, what number is B? No. What number is B? 1. You go to the table at 1. F of B is -4. So the top one, -4, subtract. Sarah, what is f of A? Four. Elia, what is B? No. What is the letter B? B is 1. Is that what you said? Oh, I heard 4. It's these masks. What is A that goes to Anisha? Or, yes. So when you plug this in, you're going to want to make sure that you do minus a negative. So -4 minus 4 over 1, subtract -3. You have about 10 seconds and then I'll pull somebody's stick. I only have 2 left. Okay, fire, what does this rate of change go to? Thank you. -2. So the range that they gave us, -3 to 1, this graph is decreasing by 2. So it's going down 2 over 1. Okay, 2 more, and then you start doing them on your own. Everybody's stick is back in. So number 3 is 3 times 2 to the x minus 2. If you're using Desmos to evaluate this, you have to use parentheses. So what that looks like on your paper is 3 times 2 to the negative 2 minus 2. So when I plug that into Desmos, or whatever calculator I'm using, but Desmos specifically, I do 3 times 2 shift, and you need to use parentheses or the minus 2 won't stay in the exponent. So you do x minus 2, just kidding, negative 2 minus 2, and that one gives you a decimal. So you can either do 3 out of 16 or 0.1875. It's up to you. So because I'm here, I'll do negative 1 for us. All I have to do is take that negative 2 and change it to a 1 instead. So that one is 0.375. And then I'll change it one more time to a 0. And that gives us 0.75. So our first 3 are really small numbers. But then after that, you get whole numbers. So you guys evaluate it for 1, 2, 3, 4. Well, actually, the next one's a decimal, but it's easy. I'll pull sticks.
So there are definitely some extra ones up there that I could use.
Okay. Okay. I don't care when you do it. Yep, if you need me to move kids, let me know. Cheyenne, where's Cheyenne? Raise your hand where she's sitting. Yeah. Okay, will you move one table over just for today? Okay. No, you're totally fine. Okay, about 30 seconds. $20. $10. Okay, so X is 1 goes to Zach. Great, 1.5. Sorry, I'll switch over to the doc viewer. Okay, X is 2 goes to Hugo. 3. X is 3 goes to Cheyenne. 6. X is 4 goes to Zane. 12. So if we need to know our parent function, which is helpful when we graph, we go back to page 17. And we look at the one that matches the best, and hopefully we're recognizing that it's the exponential function. So he looks like a curved line. He's a curved line. So I'm going to write down that parent function, y equals 2 to the x, and he looks like this. I'm just writing it down for my reference. So I use this parent function to determine, well, what did I do to this parent function to get 3 times 2 to the x minus 2? So the first thing I did was change the size. Did I stretch it or shrink it? So you look at your number. Your number tells you if it is a stretch or a shrink. If you need a review on that, it is on 18 and 19. You have 30 seconds to decide, and I will pull somebody's stick. Everybody's stick is going back in. Is this a vertical stretch or a vertical shrink? You got about 30. $20. $10. $5. Okay, Fire, do you think it's a stretch or a shrink? It is a stretch, very good. A vertical stretch by 3. It's a shrink if it's a fraction. If it's a whole number, it's a stretch. If it's a fraction, it's a shrink. Now this minus 2 is trapped with the x. So you guys decide which direction did we shift. It's either left, right, up, down. You have only about 15 seconds to decide on that one. Did we go left, right, up, or down? Okay, well, I guess you just gotta go then. About 10. 5. 3. Okay, Ivani, which direction did we go? To the right by 2. We went to the right 2. So we took this curved line and we stretched it by 3 and then shifted it right 2. So now that we know the basics of what this should look like, we can graph it. And I'll help you with those first 3 points because they're kind of crazy. So at -2, you're very close to the x-axis. So basically, the point looks like it is on the x-axis. That's how close you are. And then at -1, you're just slightly higher than that. At 0, it's like right underneath y is 1. So those 3 are all really close. And then from there, it stretches out. So at +1, you're at 1.5, so that's in the middle of the box. At 2, you're finally at a nice intersection, so 2, 3, 3, 6, 4, 12, and he's just a little bit above. Can you guys see how that makes this curved line situation right here? Can you see the curved line? So this has arrows on both ends, so I usually just like sketch it. I don't really ever make it super duper nice. Sometimes I'll highlight it and that makes it look a lot better. So on these ones, you just do the best you can to make it look somewhat like it should. Okay, what is the domain? So you go to you look at the left-hand side of the graph. This has an arrow. So if the leftmost part of the graph has an arrow, that's always negative infinity. So our lower bound is negative infinity. And now this is going to sound weird, but you go to the rightmost part of your graph. So that's this arrow right here. And even though he's pointing up, that means that X can go as far right as possible because there's an arrow right here. So it can go to positive infinity. So even though it looks like it's going straight, as you move to the right, it just moves out a little bit each time. So just, it's only a little bit, but if you go forever, it'll continue to move to the right. Okay, for the interval -2 to 0. So you guys on this one really see if you can mark that on your graph, because you're going to have to do at least one of these all by yourself. So see if with your pencil or whatever you can do 2 straight lines like I've done here to mark the interval they're asking you for. So really give that a try. Pencils should be moving. If you want to answer the question, you're welcome to do that. It's about 4,000 degrees in here, family. Okay, about 10, and I'll mark mine. Can't really use a stick for this one. 5. So they want us to go from -2 to 0. So I have that little section. So all you look at is that little section that I have highlighted. You decide, is that going up or is it going down? Which one do you guys think it is? Up or increasing? So in this interval that they gave us, the function is increasing. Okay, last question is, what is the average rate of change from x is 1 to x is 3? So this goes back to our A. Our starting point is A. Our ending point is B. We need to know f of B and f of A so that we can plug it into this rate of change formula, which is just fancy for what is the rise over the run. I personally think that it is easier to use your table to answer this. So if I go to the table, I can mark this is A, this is B. So these are the numbers that I use for that formula. So 1.5 is f of A and 6 is f of B. So now that I've plugged or written that down for you, use the formula now, this formula, to find the rate of change. Okay, I'm gonna pick somebody's stick in like 10 seconds. Five. Hugo, what did you get? It doesn't sound quite right. Is that what you guys got? 6 subtract 1.5 over 3 subtract 1. Sarah, what did you get? Say one more time. 4.5 over 2. Okay, that simplifies down to 2.25. So I'd change it to 2.25. Or 4.5 over 2 would be 9 over 4. The fraction is 9 over 4. Either one works. So on this graph, from 1 to 3, you're going up by 9 and over by 4. Okay, skip 4. 4 is one that I'm going to have you try on your own. And let's do 5 together. So we're on 5. Okay, once again, because this is a cubed function, we want to be really careful that we're using parentheses. The good news is all of our x values are positive. So for the first one, you're going to have negative 2 subtract 4 to the third. So if you're using Desmos like I like to, you just go to that screen. Don't forget your negative. You hit negative parenthesis 2 minus 4 parenthesis shift 6 3. That one gives us a positive 8. So 2, 8. Once you plug it in the first time, it's really easy now to just go through and change that first number. So all I have to do is backspace and change that 2 to a 3. And that gives me 1. And then I can quickly change the 3 to a 4. That gives me 0. Okay, you find the next 2. Give you roughly 30, then I'll pull names. $20. About 10. $3. Okay, Zach, what did you get when x is 5? -1. And Cheyenne, what did you get when x is 6? -8. Okay. What is the parent function? Y equals x cubed. How do I know? Well, I could go to our page that I've been talking about, and he's the second one. So he looks like a parabola where one of the sides has been bent down. It's like somebody took this left-hand side and bent him down. So he's just like this curved, really weirdly curved line. Okay, so let's talk about what we did to this one, because this is the first one that has a negative on the front. Does anybody remember what that negative means? Reflect. So we reflected this, which means if he was a smiley, we turned him into a frowny. If he was a V for absolute value, we turned him around to a triangle. We only did one other thing. We either moved left, right, or up, down. You guys take about 15 seconds to decide which direction did we go. Left, right, up, down. About 5. Okay, Zane, which direction did we go? Perfect, right 4. So what this means is we took our vertex of being at 0, 0, and we moved our vertex to 0, 4. Am I lying to you? Yes. 4, 0. Because we shifted right. So it was at 0, 0, and we moved it to the right 4. And that is in your table. 4, 0 is a point in your table. Okay, so let's use our knowledge of what this should look like and put our points down. So we have +2, +8. +3, +1, 4, 0. 5, and this time -1, so we drop below the x-axis. 6, and -8. So this guy is a little bit harder to see, but because we reflected him, he starts up here at the top. I'm just finding a darker color. And he curves down through the x-axis and keeps going. So this is what we did to that cubic function. If I hold up the parent, hopefully you can see that we did flip it. So normally it starts down and goes up, but we flipped it so it starts up and goes down. Okay, we only have the last few questions, and then you'll try your first one on your own. So, what is the domain of this function? So we've seen lots of these now, especially when it looks like our arrows are going up. We have 2 arrows. So remember, arrows always mean infinity and negative infinity. So even though this one looks really weird, his domain is all reals. There is no restriction on the x value that we plug in. I could plug in 100,000 and still get a value for y. Okay, for our increasing or decreasing interval, he looks a little different this time. So what they want to know is, what is this function doing from negative infinity to 4? So if I trace my finger from negative infinity to the 4, is he increasing or decreasing? Decreasing. And then lastly, they want us to find the average rate of change from 2 to 6. So A is 2, B is 6, which means if you need a little extra support, you come to the table and you highlight where X is 2 and X is 6.
She's booting up right now. I'm gonna go check on the network cabinet side, just make sure it's good away.
Okay.
It's like the third.
Awesome, thank you. Are you plugging these in? Was that a yes? About 20. Ten. 3, 2. Okay, Britton, were you able to get it? Yeah, the rate of change. Uh-oh, I got -4. Do you see what happened there? Did anybody else get -4? Okay. Okay, so I know that this is a lot of stuff to cover, so before I have you do the last one all by yourself, I want to flip back to number 4, and I want you guys to do this one without me, but I'm going to give you the answers. So I'm going to give you like 3 or 4 minutes to do the whole thing, then I'm going to show you the answer. And then the last thing you'll do today is number 6, but I'm not going to give you the answer. Does this make sense what's happening? Okay, so I do want to give you a little bit of support. So if you're plugging this into Desmos, your absolute value function should be next to the 7. If you have a bigger keyboard like I do, your absolute value function is next to the 7 in Desmos. I'm going to pause the video for the distance learners and come walk around, and then I'll unpause when it's time to check answers. I forgot to unpause, so if you're a distance learner, check your answers against mine. This average rate of change is 0 because if you draw a line through those 2 points, it's a straight line. So now, turns out, this last question, number 6, number 1, he is very similar to this first one that we did. So if you need extra support, you're going to want to come and look at number 1. Second, this is your test for this unit. This one question. Do it, turn it in. Do you understand what's happening? So are you going to do a good job? Yes. If you are a distance learner, you need to finish question 6. Take a picture of it take a picture of all 3 pages, convert it to a PDF file, and email it to me. If you don't know how to convert your picture to a PDF file, you need to email me so that I can give you instructions. So if you are a distance learner, your test is the same. You need to go through and finish this question that you see behind me on the screen, number 6. Take a picture of this whole thing or bring it to the school, whatever you prefer, and turn it in. Okay, that's it. Good job. Ready, break.